All right, for lesson 404, this is where we left off in class, talking about the different properties of logarithms, and I gave you a few examples of what they look like exponentially. So we're going to use these properties to help solve some equations. So here we go. Notice that I have the properties down there in the corner to help us along. So on this one, it looks like, first off, they're being added together. And the next thing that we notice is that we have, let me find my pen, that we have this 4 right here, which we know that that's a power function. So what I'm going to do is go over here. Hold on, I'm changing my pen colors so I'll have different colors going. Okay, so the first thing I've got to do is, since I know that 4 is a power, remember kind of like your PEMDAS, you're going to do parentheses, exponents, and all that first. So then my first step is to move that over. So I'm going to rewrite log A 7 plus log A. And now if I'm moving this 4 over, this is what it looks like. Log A 3 to the 4th power. I can go ahead and calculate that 3 to the 4th power, and that is going to be 81. So I use the power property to decide what I was going to do with that one. Now that they're being added, if you look at your product property, when they're being added together, we can convert it to multiplication. So I'm going to have log A 7 times 81. And like I said, I use the product property to change that. Now I can go ahead and do that multiplication. So my final answer is 7 times 81 is 567. Now I can't work it any further than that because I don't know what the base is. It's A right now. If I knew what it was, I could go ahead and do my change of base formula and put it in my calculator. So let's look at B. On this one, there again, this 2/3 is a power, so I'm going to have to move that over, and so I'm going to have, and that's a natural log, and I'm just going to write this up here, 2 to the 3rd minus, I got a natural log, 5 squared is 25 minus 1. And there, that was my power property. Next, I'm going to go ahead and say, calculate 8 raised to 2/3. So that's going to give me a natural log of 4 minus a natural log of 24. Now, I notice from my quotient property that since those are being subtracted, I can rewrite that to look like this. Hold on, my brain kind of went blank. 4 divided by 24. And you can always put those in parentheses if you want. And we know that our base here, since it's a natural log, we know our base is E. So what I can do now is I'm going to go ahead and simplify that. 4 will go into 24 6 times. So now I have a natural log of 1/6. And remember our property right here, it says if I ever have 1 over a number, then it becomes a negative log. So I'm going to since I'm running out of room at the bottom, I'm going to change this to natural log of 1 minus a natural log of 6. That's going to give me negative natural log 6. So that's my final answer. And the reason being is that 1 is just 1. 1 times the natural log is just a natural log. So that just leaves me, which is 0, which that just leaves me with a negative natural log of 6. Alright. This one, write each of the following as a single logarithm. This is just like what we were doing before. So you see there's a lot of work going on here. So my first thing I'm going to do, I don't see any numbers in front of any of the logs. So that right there tells me that I'm not having to worry about any powers. So I'm going to go ahead, and if I look right here, I'm just kind of grouping these. That right there is an addition, and I can rewrite that as a multiplication. So I have log base A, and then 9 times x is 9x. Now I'm going to bring the rest of this on down. Log A x squared plus 1 minus log base A of 5. Alright, so my next step is, oh, and this I used the product property. Now then, for my next step, these two, I'm grouping again. These two are being added together, so I can change that to multiplication. So I'm going to have log A 9x multiplied by x squared plus 1. And then I just bring down my log base A of 5. And on that one, again, I'm using the product property. Now, if you see, I'm left with a subtraction. So whenever we're subtracting, we can go ahead and write that as a division. So I'm going to have log A, and then up here in the top, I've got 9x multiplied by x squared plus 1 all over 5. And then we can actually go ahead and simplify that even more by saying 9x cubed plus 9x over 5. And that's it. And so this step right here, I use the quotient property. Okay, hold on, I'm trying to find my mouse here. Okay, on this one, it says use the rules of logarithms to expand, and you notice we actually have bases on all of these. So we're going to be able to go ahead and calculate it as far as possible. So here I see that 25 and x are being multiplied. So I'm going to change that to addition. And I can do that because of the product property. And then you can go ahead and calculate what log base 5 of 25 is. So, you know, we got to use our change of base formula. And we can't do that with when we have the variable x, but we can simplify the first part of the addition problem. So remember, when you have your log, and this is a 5, This is a 25. So when I use my change of base formula, I put that in my calculator. That's going to equal 2. So I'm going to have 2 plus log base 5 of x. That's my final answer. I can't simplify it anymore because I don't know what x is. So on this next one, it's using division, so I'm going to use that quotient rule to rewrite it as a subtraction. So I have log base 2 of x cubed minus log base 2 of x minus 3. But let's look. I've got that x raised to the power of 3. So I've got to go ahead and move that out. So I've got log base 2 of x minus log base 2 of x minus 3. And so there I use the quotient rule and the power rule. And I simplified that, or I expanded that as much as I could. So let's look at this last one. And remember, if we don't have a base, we know that's a 10. And of course, I've got division going on here. So my first step is I'm going to write that out as a subtraction. I don't need to put the 10. Minus alright, so on this one, I can, since that x is being multiplied to x plus 2, I can break that one or expand that one even further. And then on the last part, I'm still going to have my minus sign, but I've got that power of 2, that exponent that I can move. And that's as far as I can expand this problem. Alright, let's look at these. Now, we've learned how to make all these changes. Now we're going to actually go through the process of solving. So on this first one, I'm going to rewrite this. This is the power rule. So I'm going to say log 5 x squared equals, can't make any changes to this, so there we go. And since they have the same base, we know that when they equal each other, look at this last one down here. It says if log base a of m equals log base a of n, then m equals n. So I can bring down the x squared is going to equal 9. And then we know how we're going to get the square root of each side. So x equals plus or minus 3. But we don't really have negatives when we're working with logarithms. And you can read this in the lesson. It says negative 3 is extraneous. That's what we call it, because we don't do the negatives, is extraneous and must be discarded. So that just means my final answer is going to be x equals positive 3. Alright, let's look at B here. There again, let me see. Excuse me there, I just had a little coughing fit. So, I'm going to rewrite this logarithm as an exponential form. So that means I'm going to bring down x squared plus 7 equals remember my base is 2, equals 4. That makes 4 my exponent. So if you don't remember how to do that, you go back to the very second slide we looked at, to where we change exponential forms to logarithmic forms, or we can change logarithmic forms to exponential form. So on this one, I'm just going to work this out step by step. 2 to the 4th power. You see, 2 times 2 is 4. 4 times 4 is 16. Now I'm going to subtract 7 from both sides. That gives me a 9. And there again, we usually would say plus or minus 3. But anytime we have x equals a negative number with a logarithm, it's going to be extraneous. We just get rid of it. So our final answer is just going to be x equals 3. Alright, finally we're getting to our firework concert question. Hold on, I'm enlarging my notes so I can see them there. Okay, so it says an equation for loudness, which is a capital L, in decibels is L equals 10 log base 10 of R, where R is the relative intensity of sound. So we're going to solve. We know we're given that our L is 130 decibels. And it equals 10 log base 10 of R. And we're going to find the relative intensity of a fireworks display with the loudness of 130 decibels. So this L right here is my 130 decibels. Alright, so to find the relative intensity, I'm just going to rewrite the problem first. I got 130 equals 10 multiplied by log base 10 of R. Now, I can divide both sides by 10, which is this right here, that 10. So I get 13 equals log base 10 of R. Now, I know that, remember, what I'm gonna do now is I'm gonna convert this to exponential form. So I know my exponent is 13 and I know my base is 10. So I'm gonna have 10 to the 13th equals R. So that's what my relative intensity is going to be for the fireworks. Now we're going to do the same thing to find the relative intensity of a concert that's at 75 decibels. So obviously we know 130 is louder than 75. So we do know the fireworks are louder, which if you've ever been to a concert, I just find that hard to believe. But if you're standing right by the fireworks, I guess that makes the difference. So we're going to set this up just like we did last time. And then I'm going to divide both sides by 10. So I get 7.5 equals log 10, base 10 of R. And now I'm going to rewrite that in exponential form. So I've got 10 raised to 7.5 equals R. So now I'm going to move to part C, which says how many times more intense is the fireworks display than the concert. In other words, find the ratio of their intensities. So you're going to put 10 over 13 in your calculator. You're going to put divided by 10 raised to 7.5. And I'm just going to round that. Well, this is an approximation, not an equals. It is 316.228 times more intense. The fireworks is more intense than the concert. So that is it. If you guys go through this recording, you have any questions, just let me know. I'm here to help.